Authors, have you ever felt like your paper submission didn't receive the careful reviews it deserved? And reviewers, have you ever been assigned to papers that you felt insufficiently expert to review? Have you ever been assigned to too many papers, or significantly more papers than your peers? All of these undesirable outcomes are symptoms of our unfair peer reviewing system. You see, large conferences like KDD, ICML, and NeurIPS receive thousands of paper submissions. To review the submissions, the conference program committee enlists the help of thousands of reviewers. Typically, each paper must be reviewed by multiple reviewers, and each reviewer has an upper and lower limit on the number of papers they may review. Matching of papers to reviewers is performed automatically. Each reviewer paper pair is automatically assigned a score that represents the suitability of that reviewer for the paper. Higher scores are better. Today, most conferences and conference management platforms construct the matching that maximizes the sum of scores among assigned reviewer paper pairs. But this approach can lead to some pretty unfair outcomes. Consider this simple example of reviewer paper matching. Here, the matching with the overall highest score is the one in which reviewers 1 and 2 are assigned to papers 1 and 2, and reviewers 3 and 4 are assigned to papers 3 and 4. In this matching, papers 3 and 4 are assigned to the reviewers that are more likely to provide inadequate reviews. We present two algorithms for more fair matching. The first is the fair paper matching via iterative relaxation algorithm, or FAIRer. FAIRer begins by adding additional fairness constraints to the reviewer paper matching problem. These constraints lower bound the sum total score of the reviewers assigned to each paper. Since adding these additional constraints makes the problem computationally hard to solve integrally, FAIRer leverages linear programming algorithms and iteratively solves the relaxation of the problem, yielding fractional solutions. Then, FAIRer freezes specific assignments and drops carefully chosen constraints, eventually leading to an integral solution. We formally prove that FAIRer always returns a valid solution and never violates the fairness constraints by more than a small constant. FAIRer can even be run with lower bounds on reviewer loads. Our second algorithm is FAIRflow. FAIRflow is twice as fast as FAIRer and up to an order of magnitude faster than other fair matching algorithms. FAIRflow works by solving a sequence of specifically constructed min-cost flow problems. The central idea of FAIRflow is to iteratively reroute high-scoring reviewers from the best-off papers to the worst-off papers. While FAIRflow has weaker theoretical guarantees than FAIRer, in experiments with real conference data, FAIRflow achieves competitive treatment of the worst-off paper when compared to other fair matching algorithms. If you'd like to find out more about our algorithms or use one of them for your conference, read our paper, stop by our poster, and feel free to use our code.